Okay, so how do you calculate the number of moles in a sample? So in this case, we had a 40, so here's our formula. The number of moles is equal to the mass of the sample divided by the molar mass. So in this case, I think it was 40 grams, and it was a sample of sodium hydroxide, which was Na, which I believe has a mass of 23 sodium. Oxygen has 16, and of course that last hydrogen has 1. So the whole thing comes out to a mass of 40. So in this case, it was set up very nicely. So the number of moles ended up being equal to 40 over 40. And that turned out to be 1. Now, there's a couple of things in case you're uncertain about what you're doing. I recommend thinking about what would happen if you changed a number. What if you had a bigger molar mass, a molecule with a larger molar mass? What would that do to your total output? So if you had a larger molar mass, then you'd be dividing, you'd have less moles. Does that make sense? Well, let's think about it. If you got a 50-pound bag of peanuts, there are many more peanuts in a 50-pound bag of peanuts than there are coconuts in a 50-pound bag of coconuts. Make sense? The bigger the thing is, the less of them you're going to have in a sample of a given weight. So that's one of these things where if you think about it, if you're not sure whether you're supposed to divide or multiply, ask yourself, what would happen if we change something? If you had bigger molecules, would you expect to have more of them or less of them in the same size sample? So that's one of the things you can do just to make sure you're on the right track. There's another thing you can do. I'm going to see if I'm still in the shot here. Okay, so we're trying to find the number of moles. Look at your units. You can throw units into any equation. So we had 40 grams in the sample, and we have a mass of 40. Now, what is the unit in a molar mass? It is grams per mole. I forget whether it's MOL or MOLE. Anyway, we're just going to go ahead. So there's grams per mole. Now, the grams are going to cancel. This mole is on the denominator. When you got a number on the denominator of a denominator, you can just simply put it on the top. So what do we end up with? You could simply move it to the top. And so you've moved to the top and you've got the right unit. But if you got something like 1 over mole at the top, you know it's not right. Or if you got totally the wrong unit, you know it's not going to be right. So these are ways of doing it. There is another easy little trick, is you create a T chart, or a T table, or whatever they call it. It has a T, and I'm thinking this is still in here, so you got a T. So you got the number of moles, you've got the molar mass, and on the top you got mass. I know they might seem like, oh my God, that was so junior high school, but they work, and you can use it for anything. Okay, you want to find the number of moles? Mass divided by molar mass. You want to find the mass of a sample? The number of moles you got times the mass of each mole. You want to find the molar mass of an object? Take the mass divided by the number of moles in that mass, and you got the molar mass. So there's all sorts of ways you can approach it. But I always recommend just thinking about, one, using the units. I always tend to drop the units because I don't like writing a whole mess of extra stuff. But the units are what are going to tell you if you're doing it right. If you got units, if you finish the equation and your units are all wrong, then your math is all wrong. I also recommend you start asking questions. Okay, what would happen? Are we sure the mass belongs in the top? Well, let's think about it. What would happen if I change the mass? is there more peanuts in a 100-pound bag of peanuts than there is in a 50-pound bag of peanuts? Of course there are. So we know that, yeah, the mass does belong on the top, because more mass is going to mean more moles, right? So you just think about those. Think about the things. If you're not sure what you're doing, if you're not sure what you're doing is right, think about how changing one of the variables would change the outcome. That's going to make a big difference. Because if you have something in the wrong place and you think about changing it and it gives you a totally crazy outcome, then you know that's probably not right. So I hope this has been helpful. It ran a little long. Usually I keep my videos to a few minutes, but anyway, I hope you enjoyed it. I'll make another one for concentration.